So my name is Dave DeBari. I have been here before many times telling you about where we're at in OPA. I get to be the ExxonMobil OPA program technical team leader. In that, I have been working on proof of concept, prototype, testbed, Lighthouse project, and I'm going to start the presentation to tell you about sort of where we've been and where we're at today. Tell you about a little success we've had recently. And then I will turn it over to Kelly to tell you about the future of where we're going to take it. All right. So we've been doing this a while. About 16 years ago, our chief engineer, and you probably met him, Don Bartusiak, at the time. He's retired from ExxonMobil at this time. But he stays active with the forum, thankfully. He came here and told everybody about this crazy idea we had. What if we use standards and open architecture and all the features that might be available in technology today and change the way the system would work? And this all stems from a problem we had with obsolescence. If you're going to make a change, then maybe we ought to talk about the kind of change we really want to make, and that's where it started. So we spent several years, and literally 11 years he came here and he said, this is what we're thinking, and we got a mixed review. A lot of people said, yes, we have the same thoughts, and other people said, well, this sounds a little crazy, but that's all right. I joined the team about 13 years ago, and so I worked in the background, and we were working on our ideas and our thoughts and our designs, and then we started working with a company to make this possible. And about 8 years ago, I got to come here and tell you about how the proof of concept went. It all succeeded. We tried our things. I brought it back, but I stood on stage, and you don't want to know what a distributed control node is? It's a device like this with I/O, and if you want to change the processor, you pop it out and you put another one in. You can replace it if it fails. You might change it from silver to purple or blue or brown or black, whatever it is. It's all based on the workload you're trying to run. But this is where we started with our idea: replaceable, interchangeable, interoperable. 7 years ago, we did our proof of concept, the results. 5 years ago, we told you about the prototype. So we went to a pilot plant in one of our facilities. We let an operator run this unit for several months, and they did not gripe about it, so that was a good sign. As we all know, the operations can tell you how good an engineer you are really fast. I'll tell you, in the FAT, it took them 6 minutes to find the first mistake we made. So we're here to tell you today about what we did with our Lighthouse project. And this is a commercial instantiation of OPA architecture. We ripped and replaced an existing control system and put in this OPA architecture. And I'm going to tell you about some really good success on that. I wanted to point out that part of what we've done is a lot of innovation. And innovation surrounds three main topics: ambiguity, uncertainty, and risk. And the whole goal about innovation is, how do you deal with it? And part of innovation is you need to learn to kind of love these things. You need to be able to hug the risk. You need to be able to be happy with your uncertainty. And living with ambiguity is just the state of how it is. When we were doing the Lighthouse project, I had a project manager say, what is this going to look like? I said, I can kind of describe it, but I don't know yet. And he said, so you're going to deliver just-in-time technology? And I said, yes, that's exactly what we're doing. Okay, so the Lighthouse project itself. At the end of August, we finished our factory acceptance testing on the build. And we packed it up. We shipped it to Baton Rouge, Louisiana. By the end of September, it was installed and ready, and we did our pre-startup safety reviews and all the other things that go with setting up a system. We started the process of doing hot cutovers. So about a third of the system was hot cutover, and 2/3 of it we had to wait for a shutdown so we could do a cold cutover. Processes that didn't have a second or a third. We have multiple boilers, multiple heaters, systems that could go down, and then there's systems that can't go down. We did our plant outage at the beginning of November, and then by November 17th, and that's a Sunday, we turned this over to operations early. If you've ever been part of an automation project and you hear the words you turned over early to operations, that's special. And it is amazing that we did it and it worked. And the best part is the next day they made product that went through the lab and was ready to sell. So this is, we think, serial number one, commercialization of OPA architecture using the OPAF as our guide system and making product, making money for our company. Today it is running stable. I'm not going to tell you we haven't had to dot a few I's, cross a few T's, polish here and there as we go along. As I said, the operators have had it, so they're finding the few weaknesses in our engineering talents, but that's okay. They've continued to run. We've been able to do things while they're running, and they are happy with us. They are not cursing us when we come to the control room, and they're not wishing us ill, which is a good thing. And we're happy because it's been a long time coming. I showed you the timeline. It is years to get here, but we're here, and that's our message. We've done it. It works. It's not that hard. So I wanted to share a few things about our project itself. In the preparation, we did use OPAF version 2.1, which is the current released version of the OPAF standard. We did a very long, thorough FAT. We had to make sure that this system would work for operators, be safe, be reliable, and they could successfully make our company money every day. This was not a pilot unit. This was not a proof of concept. This is a unit that has a responsibility to stay online and sell product. We finished ahead of schedule. And I would say all this preparation and the effort of the team that I was allowed to lead really delivered this. In the engineering world, we mastered some new tools. And we figured out how to build this system, which has been sitting here for decades with the legacy system, and reinterpret it using the new tools. So not only we bring new hardware, we also brought some new tools. So we did think about it. We didn't go crazy with it, but we did not just Xerox copy what we had. And then, of course, using these tools, you start really liking the new tools and capabilities. And I tell people this, once you start doing some of these things, you kind of can't go back because it's like stepping back decades in technology. No longer have a PC, you have a tablet of paper and a ruler. I mean, it really feels like that once you use these tools. From the manufacturing side of things, I say this, the operator is your toughest critic. They're also one of your best assets. And so their ability to find the mistakes and you thought it worked this way and it really works this way, that's not how we do it. That's not the same range we've been using for years. That's what's in the drawings, but you know how that goes. That was excellent. The thing that we really got was the feedback. So I've been around migrations and DCS projects. Actually, this system is my 21st in my career. I've done 11 brownfield conversions and 10 greenfield installations. And when you do brownfield, the one thing you have to overcome is they like the old system. They're comfortable with the old system. They know how to use the old system. And it usually takes several months before they start to realize, this is the new way and it's not going back. And we're starting to like it. And literally in less than 3 weeks, I started hearing good things. And they weren't talking to me, they were talking to each other. And that's very cool. We went from it works, surprise, we worked a lot hard to make it work. And they said, it works actually better than the old system. And I heard that, two operators talking to each other, and then they started showing each other tricks they could do. Hey, it'll do this. That's a good thing. And then they will tell us, we were worried when you started this. It might not have worked, but we were worried. And then they converted, and literally within less than a month and a half, they said, hey, we could add changes to this. We could make it better. And think about where you get to with a new system, where you get to the point where I can start making the normal life cycle changes, process changes and equipment additions and range changes and graphics changes, and they're just treating it like it's another DCS system, which is what we wanted, but it's so soon. It's a good feeling. The power of modern technologies is an amazing thing. And again, like I say at the bottom, they have started back into their normal cycle of making changes to their plant and their process, and that entails changes to the automation system, which is an OPA architecture system. We did rip and replace, and there is not a piece of the old DCS system sitting there. It's not left in the corner, go back to it, it's gone. So this is a commitment we've made. All right, so a few things that we built skills on. And I tell you this because if you want to do OPA, there's a few things you do have to start understanding. These are skills that may not be common in current automation systems, but in the future automation systems, these are going to be the norm. And I tell you this because you're going to have to learn a little more algebra, but there's no quantum physics here, okay? Every time we've had a technology change, whether it be the introduction of HART, OPC, the classic version, we've learned how to master those. Even going from serial bus to Ethernet, we figured this stuff out. And this is along the same lines. Obviously, in the cybersecurity world, 62443 is the standard. We used hardening, and we did secure device onboarding. And this is all part of that supply chain stuff. Role-based access control, zones and conduits. We do not have a production zone and a management zone. We have like 27 zones. Okay, so when you think about actually using cybersecurity, there are devices that really shouldn't be able to talk to other devices. Train 1 shouldn't talk to train 2. So these are the kind of things. Our cybersecurity people are already getting up to speed on this. This is something you're going to do anyways at some point. That's part of this too. Automating the automation system. And here's one of those things. If you ever try it and start using orchestration, you will never go back. The true automation of the tasks, and I mean, we're process control engineers. We're great at automation. We should love this stuff. It brings systemness and the ability to introduce new technologies. Automating the workflows. Now, we did deployments, and I've told this story before. We can literally take one of our controller computers out of the box. The moment you cut the tape on the box, mount it on the DIN rail, plug it in, install the software using orchestration, it is talking to I/O running control logic in less than 20 minutes. Try that with your existing systems. 20 minutes, it is running. That is orchestration. OPC UA is the definition of interoperability with the OPAF standard. If you use OPC UA and you use the information model in the OPAS, plug and play becomes a reality. We have used a full suite of OPC UA utilities, Global Discovery Server, Alias Server, Certificate Authority in the GDS. So when you start using it at that scale, you start to realize how much is really there. We did use OPC UA between everything. We talked from computer to I/O, computer to HMI, computer to historian. A lot of our devices speak OPC UA, and you start to realize this is what it looks like when everything speaks the same protocol. We built an advanced computing platform, and the translation is that is your OT data center. This is where your servers are today in your existing system. Here's where your engineering tools are, and your other central utilities, domain control, user, all that stuff. We believe that we've built a really big one, but we did it for the program to prove the point. But we do believe there is room to have a small, medium, large, extra large version and a good, better, best model. It's all about how much do you want to do, how much money you have, and what features are you looking for. We used hyper-converged infrastructure. That's not a requirement, but we wanted to know if we could. We did virtual machines. We're all pretty familiar with that idea. All of our software is containerized. So our control logic and our communication is containerized. And if you don't know where software containers are, that's something to learn about. And once you learn about it, again, you'll go, wow, this is great stuff. And we do have virtualized controllers. So we have Linux VMs that run control, time sensitive, not an issue, no latency problem, no barely making it. It works very well. And then the last piece is about the IT technology in the OT space. We have to remember the OT sensitivities. This is not a data farm we're running. It's a machine. It's got chemistry. It's got energy. There are people working around it. The risks are real, but the IT tools are very cool. So use of Linux is kind of new in our world. It's not new to the world, but in the automation world, it's not as common as you might imagine. We ended up we built a mesh network, setting up firewalls for VLANs. Big thing. So the last piece is we look at this and you talk about it. We went from innovation required to new ideas, and new ideas need friends. We came here and told you about it. Opposition starts because some people don't like to change. And of course, the OPA standard becomes the normal. So at this point, I'll hand it over.
All right, thank you, David. Good afternoon, everyone. Okay, I'm Kelly Lead, also with ExxonMobil, and I'm the commercial lead of our Open Process Automation initiative. I'd like to say I'm very excited to join the OPA teams just about a year ago. Didn't work on the program as long as David and some other team members, but very excited to join the teams. I have been with ExxonMobil for 19 years, so this is my 19 years with the companies. You must think I look much younger than my age, so I might started working when I was 10 years old. Anyways, so since I joined the teams, I've been leading the commercialization efforts, which is to look for new business opportunities to deploy the OPA solutions, which you'll hear more about later. But this, I said, 19 years with the companies, most of my career spent in automation and optimization areas. And I have to say, OPA is the most innovative and transformative initiative I have the privilege to work on. So I'm very, very excited to build on the team's excellent work in the past decade or so and work towards to a future where the industry embraces more open architecture. With that said, I have a couple of slides to cover for our commercialization plans. I think I have 20 minutes. So now, with OPA being a reality, what comes next? And what comes after our Lighthouse project you just heard about? Commercializations and moving into more deployments is what's next for ExxonMobil. Our objective is to encourage an industry shift towards open, secure, and standard-based systems. That is through our decisive capital allocation. What does that mean, capital allocations? With the completion of the Lighthouse project at the end of last year, and ExxonMobil also concluded our own R&D activities, we are moving shift to become the smart buyer in the marketplace. We're looking for commercially available solutions in the markets. That is for our next deployments. Making our capital investments of our upcoming automation project on solutions that is meeting our OPA requirements based on the OPAF standards, giving us the automation systems that is intrinsically secure, have open architecture, and more of these OPA deployments should be occurs in the next few years. We hope to see a shift from the industry, not just by us, by other end users as well, to have further adoptions. Understanding the industry doesn't shift overnight, and we do have a scale-up plans as shown on the slide here. Starting with our first commercial deployment, the Lighthouse project you just heard from David, it has demonstrated the open OPA system capabilities of providing the same functionalities that we expect from traditional DCS and PLC system. Plus, added benefits of a modern automation systems also demonstrated the performance of a system with hardware and software components coming from different vendors, allowing interoperability. The Lighthouse project also established a support model with a single point of contact as our sustainer, who will be responsible of coordinating with all these individual components vendors, providing a long-term sustainment effort. I'm also very excited to share with you that the Lighthouse project and the completions has been featured in our recent ExxonMobil Corporation's newsroom articles that was just published yesterday, celebrating us being the first in the world to deploy the OPA solutions at scale in the commercial settings. really pioneering these technologies that could transform manufacturing. Next, the focus of my commercial role is to look for more deployment opportunities. And starting the last year and continuing on this year, I'm working with commercial teams that actively working with our business lines that include upstreams, midstreams, downstreams, and low carbon solutions business to identify our next deployment opportunities. We are progressing with some smaller scales, lower complexity system as stepping stone project. And we want to leverage this stepping stone project to start capturing the benefits of OP8 and also build up the experience curve with the OP8 project executions and the sustainment effort. Next, as the marketplace evolves, we anticipate the developments of OP8 ecosystems with multiple suppliers, system integrators, and end users who are demanding more OP8 solutions. Such ecosystems will offer commercially available solutions for all complexities of products and have a more mature sustainment models to support lifecycle management. Recognizing the importance of ecosystem development, and after leading the charge in the leading space in OPA for the past decades or so, as I mentioned, we are concluding our R&D efforts last year and now creating more space for others to collaborate and participate in the standard settings committees. We work with multiple suppliers to screen potential use cases, co-develop solutions that will meet our, that's based on the OPAF standards and meeting our OPA requirements. Making our investments in the automation space that is meeting our requirements and becoming a smart buyer of OPA solutions. In the meantime, we are also collaborating with other end users similar to us, and not just in the industry, not just in the energy sectors, but also with other companies across a wide range of sectors. ExxonMobil has formed an OPA collaboration partnership with 10 other companies to share non-competitive information and the use of testbed set up by these companies. This collaboration partnership aims to accelerate the process for these companies to move from OPA testbed to field trials and to more deployments in the actual field. Finally, working with various industry associations, such as the OPA Forum from the Open Groups, UAOs, and others, we continue to contribute the standard writing process, which are referenced by the OPA solution. So in summary, we see that the commercialization and the deployments of OPAs are critical steps towards achieving an industrial-wide adoption of an open, secure, and standard-based system. And a fully developed ecosystem comprised with multiple end users, suppliers, and system integrators is necessary to support the commercializations of OPA. Right? Okay, so that's the plans, that's our commercialization plans, and how exactly are we going to do it? So the next slide is trying to explain to you a bit more details and steps that help us to reach our final OPA visions. At the top of the slide, you can see some of our adoptions with OPAs within ExxonMobil. We transitioned our R&D efforts in the lab and testbed environments over the last decades now to actual field deployments. And we plan to scale up the field deployments in the upcoming years. Within ExxonMobil, in our adoption, we have two main tracks, PLCs and DCS. In the PLC, programmable logic controllers track, we aim to progress stepping stone project, which started in 2024, and we expand to multiple ones in the upcoming years. And on the DCS track and SCADA systems, focusing on a bit larger, medium size, and work towards to more complex. Both those tracks are working towards in the upcoming years that we aim to deploy more of the OPA solutions in a broader use cases, either integrated with multiple systems or deployed across different business lines, as I mentioned earlier, in various of our footprints in refining, chemicals, midstreams, upstreams, and also in our newest business lines, the low carbon solutions, which focusing on hydrogen, ammonia, production, carbon capture and sequestration, and lithium. So looking back in 2024, I think we have completed our goals. On the DCS track, I give myself a green check mark. We completed the Lighthouse project, thanks much to the teams, deployed and successfully cut over the whole DCS systems in Baton Rouge. And on the PLC track, we aim to identify and progress 1 to 2 use cases. That's going to be our next sub OPA deployments. And I'm here very excited to announce that we have just awarded our next OPA projects this past month. It's a PLC types of automation project in our midstream terminal. This will become our next OPA deployment after the successful completions of Lighthouse project. As part of this project, we went through a RFPs, request for proposal, or RFQ process, and specifically put in the OPA requirements in our RFP. So Harry, we are one of those 50% who actually incorporate the OPAF standards and requirements in our RFP. I was really encouraged by the levels of the commercial offerings that we have seen from the marketplace. And we received multiple proposals from our suppliers who got invited to that bid. Of course, there are various stages of the maturity from those OPA offerings, but it was definitely encouraging to me to see the OPA requirements are either already met by the commercially available solutions, or some of those products developments are already incorporated OPA requirements in their roadmap. To me, this is a real sign that the industry started shifting towards more open architecture, and even the suppliers are starting adopting to the requirements that's based on the OPAF standards. Looking forward in 2025, on the PLC track, we continue to look for more opportunities. So while the scope and the investment amounts on the individual PLC project is relatively small, however, there are many, many opportunities due to the large PLC install bases in our manufacturing sites. And a lot of these opportunities will surface to manage the obsolescence of those devices, and also new deployment opportunities in our growth assets, such as in our unconventional business in the Permian in West Texas, and also low carbon solution operation that's starting up in the lithium space. On the DCS track, I'm also excited to share that we have just identified another OPA deployment opportunities that's with our chemical business. I'm currently working with an EPC company on the front-end engineering design of FEED on that particular project, and it's a medium-scale DCS greenfield project, and we expect to send out an RFP, request for proposals, later this year, which will also incorporate all the OPA requirements. All right, so that's the adoption plans within ExxonMobil. So moving to the industry, on the second half of the slide. While you have heard ExxonMobil has been leading the ways in adopting OPAs, we are also collaborating with others to bring along to help build up the OPA ecosystem. I'm excited to see on the OPA forums, OPAF have launched the certification programs last year. I believe it's in October in 2024. That has a certification program launch allowing suppliers and individual components to be certified to meet the OPAF standards. And the forum continues to update and improve on the release standards version 2.1. With the certification programs now launched, I hope to see more of the products being OPAF certified in the near future. In terms of collaborating with other end users, we have been working with our collaboration partners, and we have seen multiple of those end users progressing from an OPA testbed into some of the field trials and eventually leading to actual field deployments. And hopefully more of those announcements will come in this year and the upcoming years. And then for the automation vendors, system integrators, and components suppliers, I hope to see more of the automation vendors, system integrators offer and again commercially available and commercially supported solutions, and that are OPAF compliant and eventually being certified with the OPAF standard. With more of the deployments of OPA solutions, the experience curve is expected to improve over time, David mentioned that our Lighthouse project is serial number ones, and hopefully in the next few early adopters, the experience curve and the adoptions of OPAs will lead to both improvements on the executions and also sustainment effort. This is the same to all the component suppliers, that we are looking for commercially available solutions that can be deployed, ready available, and meeting the OPAF standards. As shown on the slides here, as the ecosystem continues to develop, both the demands of OPA increases from the end user side, and the knowledge and experience executing these OPA projects should increase and improve from the supplier side. Which all this leads to us to the final vision showing on the right side of the slide, which is, we hope the final vision that open, standard-based, secure, and interoperable system becoming the norms in the commercial space. I'm really looking forward to a future where we don't have to talk about OPA or non-OPA product, but rather an industry automation systems that have features of open, secure, and interoperable, which helps to promote innovations and increase the returns on our automation systems. This system should allow us to easily deploy new innovative applications, like many of the AI tools that we have heard about during this week's conference, and really to provide values to our business line. All right, so this is my last slide. So what is the key takeaways I want you to walk away from our presentation? So after you heard about all the Lighthouse project updates from Dave and the commercial plans from me, here are some of the takeaways I want you to take it with you. First, it has been a long journey. Dave gave you the history. So yeah, before 2016, where the OPA Forum was formed, it's actually started way before that. So over more than a decade, thanks to many of the brilliant men and women from ExxonMobil and from the industry who had contributed to this initiative, from developing the industry standards, building the prototypes, test beds, and completing the field deployments. Their contribution helps moving the automation industry towards a more open architecture. And I now have the privilege to build on their work and through our next up deployments of OPA solutions and move even closer to the visions that started more than a decade ago. Secondly, our first commercially deployments, the Lighthouse project, demonstrated the OPA is now real and is commercially ready. It's no longer just a research project, no longer just an idea, but it's actual deployments in the fields, operating, managing our online operation. And specifically, the deployments of the Lighthouse project allow us to have an expanded selection of hardware and software building up the OPA system. The components used in this project are commercially available and aligns with the OPAF standards. It has enhanced cybersecurity capability, providing us a secure system. Third, I feel like 2025 this year is going to be a pivotal year for OPA. We will see more of the OPA transition from R&D into actual field deployments. For ExxonMobil, we are starting with our lower complexity PLC type project, moving to more complex and larger system. And all this is going to be what towards the final vision of OPA. The commercializations and deployments of the OPA in the fields are critical steps towards an industry-wide adoption. I'm very excited to see the future where the mature OPA ecosystems we're going to transform and impact our manufacturing operation. And lastly, just to close out my presentations, I call on other end users and suppliers and system integrators to step up in moving the automation industry into the future. Let's embrace the standardizations, open architecture, and realizing the benefits of lower total cost of ownership, acceleration of innovations and value captures through the deployments in the field. So if there's only a key takeaways of my takeaways is one word, deployments. We need deployments of OPA systems in the field to really realize all these benefits. We, ExxonMobil, have done it. I invite you to join us. Thank you very much for your time.